Hey, welcome back everyone to our second demo video on blockchain. As we discussed in our previous session, we discovered a significant issue with the blockchain transactions that can happen, the unauthorized additions that can lead to fund depletion. To tackle this problem, we'll be delving into the use of public and private key pairs, a cryptographic element that can significantly enhance the security of the blockchain transactions. In this lesson, we will explore the world of public and private keys and how they bolster the security of the blockchain transactions. You can learn how to sign messages using these keys, ensuring authenticity. We will apply these concepts to blockchain scenarios, highlighting their importance in safeguarding transactions. Private keys are lengthy and unique numbers that should be kept private all the times, while public keys are meant to be openly shared without any risk. When generating a public key from a private key, a mathematical process is involved. It is important to choose a long and random private key to enhance security. With each digit added to the private key, the corresponding public key changes. However, it is impossible to derive the private key from the public key alone due to computationally infeasible mathematical algorithms used in asymmetric cryptography. This ensures the security of the private key, even if public key is widely known and shared openly. It protects sensitive information and enables secure digital transactions. Remember to keep your private key safe and secure and never share it with anyone. Now, let's see how these keys work together for message signing. I'll type a message, for instance, "Hello blockchain enthusiasts." Next, I will sign the message using my private key by clicking on Sign button. Voila, we now have a signed message which contains the original message along with the digital signature. This signature is unique to the sender and the message, ensuring the authenticity and the integrity of the message. But wait, how can others verify the signature to ensure it's legitimate? That's where the public key comes in. With the public key and the signed message, anyone can verify authenticity of the sender. Alright, let's click on this Verify Signature button and see what happens. And there you have it. The green confirmation indicates that the signature is valid and the message indeed comes from an expected sender. If the signature were invalid or tampered, the verification fails, alerting us of the potential security breach. That's the magic of a private and a public keys for message signing. Combining these cryptographic tools, we can ensure the security and the trustworthiness of digital communications and transactions. Alright, let's move on to the transactions page. Here we can make a transaction of $20 from a particular public key to another public key. The private key can be used to sign the message. By hitting the Sign button, we get a message signature. The signature can be checked against the public key to see if the private key behind it signed this message. For example, let's go to the Verify section and change $20 to $20,000 and check what will happen. It turned red, which means that the signature is invalid. Now let's see how private-public key pairs and message signing work within the blockchain scenario as we discussed earlier. As you can see, the names have been replaced with the public keys in the From and To sections, and the new Signature section has been added. For example, this transaction involves a public key sending $10 to another public key accompanied by a message signature. The signature acts as a cryptographic seal, ensuring that the transaction is legitimate and originates from an authorized sender. Now let's experiment again by modifying the transaction to $250,000. As you can see, the previously valid signature has turned red. This indicates that the block has become invalid due to tampering. Although miner can successfully mine the altered block, the signature remains invalid because they lack access to my private key. That is why public-private key pairs and message signing ensure that only authorized individuals can propose transactions within the blockchain, preventing unauthorized parties from interfering. To recap, public-private key pairs and message signing provide the necessary protection to ensure that transactions within the blockchain are genuine and originate from unintended senders. The creation of a new public key address is a straightforward process. You generate a new private key, derive the corresponding public key, and make it public. No centralized authorities are needed in this context, showcasing the decentralized nature of the blockchain technology. This explanation captures the core principles that underpin Bitcoin and numerous other cryptocurrencies. To summarize, when it comes to blockchain transactions, public-private key pairs and message signing are crucial for security. They make sure that only authorized parties can access and modify transactions and guarantee that they come from a right sender. And the best part is, this approach doesn't require any central authorities to create new public keys. Thanks for joining us today. We hope you learned something new about the fascinating world of blockchain and its security features. Our next module is going to be about BNB chain and its ecosystems. See you there.